Hello everyone. In this lesson we're going to be looking at the CPU inside of a computer. Last lesson we looked at the input, output and processes that generally occur inside of a computer, but now we're going to have a much deeper look at all of the important components that a computer uses in order to do useful things. So my first question to you is to have a couple of minutes just to think about these different components that you can see on my screen. There are 6 of them. I'd like you to spend a couple of minutes just to have a think and pause the video, come back and we'll be able to talk about what they actually are. Okay, so hopefully you've given those a good bit of thought and you may have seen some before. So what are they? Well, let's start off with the first one. This is the motherboard, and this contains all the core components of the computer, such as the processor chip and the connections to all the other components. This is where everything, or every important thing in the computer sits. The next component is very straightforward. This is the processor chip, the CPU. This will be the main thing we're going to talk about in this particular lesson. It slots into the motherboard and it effectively is the brains of a computer. The next piece is the RAM chip. This is the memory that the computer uses to temporarily store programs and files that you're using when the computer is switched on. It's located on the motherboard itself, and it can be anywhere between 1 to 16 gigabytes of RAM and potentially more if you decide to have a bigger system. This one is the graphics card, and this is what's used to produce all the pretty graphics that appears on your monitor. They usually contain additional memory and an additional processor, sometimes called the GPU, and this is used for processing all the graphics of your computer. So if you play a lot of high-tech games, this is what's producing all those usually beautiful images that you see. This, of course, you probably would have seen is the hard disk drive. This is where you permanently store information on your computer when it's turned off. It is made of several disks and a head that moves around and reads the information. Apologies. This is a data bus, and this is literally just a cable that connects all of the different pieces within the computer so that they communicate with each other. The cable is usually plugged into the motherboard and is attached to other devices within your computer, such as the hard drive. That allows the CPU on the motherboard to communicate with the hard drive if it needs to store any information. So I hope that was an interesting thought experiment there. Today's objectives are to look at the block diagram and the main components of a computer in terms of their input, processor, output and storage, to understand the difference between RAM and ROM and what they are used for, to distinguish between main memory and permanent storage devices, to name the 3 stages of the fetch, decode, execute cycle, and to define hertz, megahertz and gigahertz and state how these relate to the speed of the processor. So, before we move on, the first thing I would like to do is just to bring your attention over here, where I'm going to draw a very basic person. Apologies about the diagram. And what I want to have a quick think about is what inputs do people use, what outputs do people use, and mayhaps what are the processes that a person uses on a daily basis. So I want you to have a couple of minutes just to think about a human and what inputs we take in, what inputs we give out to the world, and what goes on in between. So pause the video now, have 2 minutes to think about that, and then come back. Okay, so I hope you've had a little bit of a think about it. So what kind of inputs do humans take in? Well, the first thing that we have to think about are what are the human senses? So if I write out all the different senses, you may have thought about these while figuring out what these inputs are. So our senses include sight, sound, touch, taste, and smell. There we go. So of course all of these inputs apply to a human. So of course we've got the eyes, we've got ears, we've got touch on the hands or anywhere on your body, we've got a tongue for taste, and we've got a nose for smell. So these are all our different inputs. What kind of outputs can we do? Well, we can talk, so we can use our mouth to talk. We could sneeze, potentially, and we can move our hands to perform various actions. There are loads of different kinds of outputs that a human could do. The thing that happens in between is, for example, let me just get rid of this. Obviously we all have eyeballs, and our eyes, they take in information from the outside world. It travels through some neurons straight to the brain, and the brain does some processing, squiggly brain, and when it's decided what to do with that information, it will then send a signal, maybe to your hands, to pick up an object. So these are the parallels for the kind of things that we do inside of a computer. Okay. So how does that relate to us? Well, hopefully you can see this diagram here, and these are the core components of a computer in terms of input, processor, output, and storage. So a computer uses a CPU, and the CPU is the brains of a computer. It's what does all the thinking. And in order to function, it also needs inputs and outputs. So, for example, as we said, the 5 senses are sight, sound, touch, taste, and smell. A computer usually works with sight and sound. So, visual images and auditory images. So, sound, voice recognition, stuff like that. Those are our inputs. The outputs are usually the same as well, so we can use images on the monitor, and we can use sound from the speakers. There are loads of different kinds of inputs and outputs, but those are the main two. So a CPU could take in inputs from your mouse, your keyboard, maybe your camera, or speakers. It can process them and produce their own outputs, such as presenting that information on a screen in a certain form. In order to do that job, it also needs to have a place to temporarily store things, so it would use something called main memory. And main memory is a temporary holding place for any information that the CPU uses. If a CPU is going to store things for a longer period of time, it will use a permanent storage. A storage kind like this would be the hard disk drive, as an example, or maybe a flash memory device like a USB stick. So, in terms of computing, this is the core idea, that we have a processor, a brains in the middle, we have something that gives us input, allows us to do output, and there are places where we store information. Okay, so you need to be very familiar with how this diagram works and its significance to computing, because it is one of the most important diagrams in computing. So, our next objective is to think about the difference between RAM and ROM and what they're used for. So, RAM, it stands for Random Access Memory, and you'll hopefully have seen this inside of a computer if you have a desktop. If you have a laptop, you probably won't, because taking things to pieces on a laptop is very difficult. But ROM looks like just a stick, and it has lots of little chips on it. Now, RAM can be any particular size. It could be, as I say, anywhere from 1 gigabyte all the way to 32 gigabytes, normally. It could be smaller, it could be bigger, it depends. And the reason it's called random access is because you can access any place in RAM instantly. You don't have to do any waiting, or the computer doesn't have to anyway. This is unlike a hard disk, which has to spin around in order for the computer to read things. ROM stands for read-only memory, and ROM is usually a chip, like you'd see on a computer, like the processor, for example, but the processor is very different, and ROM means you can only read from it. And what that means is that we hard code information onto ROM, such as programs and instructions and data, and the important thing about ROM is once it's written to that ROM, it can never ever be changed. It would sort of be like if you take a piece of paper and you start writing in pen on that paper, that is like ROM. You can never rub out that pen. Now, of course, we all know that there are rubbers now that can rub out pen, but, a while ago, before we had these, you couldn't rub out pen. Now, RAM, on the other hand, is a little bit different. RAM is the same piece of paper, but we are writing instead in pencil, and as we know, we can rub pencil out. Another way of thinking about RAM is like a whiteboard, like you've all used before, where it's empty, you write on the whiteboard using your pen, and when you leave the lesson, you just rub it all out, and you can use it again for the next lesson. So, the idea of using a computer is that some information, some data, needs to be stored permanently in memory, even when the machine is switched off. Let's have a think about a few questions then, shall we? So when you turn a computer on, how does it know what to do? Well, that's a very interesting question, because how does the computer know to respond and load up and do all the things that you want it to do? Well, let's take a little adventure inside of a computer. So inside of a computer, when you press the on button, which usually looks like this, what happens is the computer goes to a particular piece of ROM, and that ROM stores all of the instructions for loading up the computer instructions. And that particular piece of ROM is called the BIOS. You may have heard of it before, potentially, and the BIOS stands for Basic Input Output System. And as I say, it has all of the instructions in order to boot up the computer and get all your programs running. And the BIOS, one of its main jobs is to load the operating system. For example, Windows, which many of you use, or iOS, if you're a Mac, or using Linux, which is a more exotic example. So it loads up Windows for you, in our case, and Windows lets you do all sorts of super duper stuff. And once Windows takes over, BIOS stops doing its job, and it takes a backseat until you need to turn the computer on again. So those instructions are stored in ROM, and in order for the computer to actually run Windows, it loads it into our RAM stick. And our RAM stick can, as I say, be anywhere between 1 to 32 gigabytes normally, and RAM is a temporary holding place for any information. What happens is, when the program is in RAM, you can run any program you want at any time. However, what happens when you turn the computer off? Well, if you consider RAM like that whiteboard that you take to lessons, you write on your whiteboard lots of information during a lesson, and then at the end of the lesson you wipe it out and you leave the lesson. The same thing can be said about RAM. Once the operating system is inside RAM, such as Windows, after you turn off the computer, it's like leaving the classroom, and the computer wipes RAM. RAM only is active when the electricity is turned on, so it's a temporary storage facility. If you were to store a file, such as a Word document, or maybe even a game, for example, what you would do is, instead of storing it in RAM permanently, you'd store it on your hard disk drive, which is the device you saw earlier that has a literal disk that spins around, and it holds all those information for you permanently. When you decide to load those things, what happens is the computer takes all that information from the hard disk and it loads it into RAM. So, for example, like we talked about the whiteboard, if you had a worksheet with a bunch of instructions, you could write those answers on a whiteboard, like you may do during lessons. And when you are done with those particular questions, you just get rid of them from your whiteboard. They're gone. However, your worksheet still exists with the questions, and maybe you've written your answers in pen on the worksheet as well, and you can use those later. So the hard disk is like a worksheet with all the permanent information on it, whereas RAM is like a whiteboard. Other examples are if you're temporarily copying and pasting an image, such as, from Microsoft Paint, or copying a document from somewhere, what happens is that document is also stored in RAM, because RAM is our temporary place in memory for storing things. The other word for RAM is main memory, which we talked about a little bit earlier. So these are interchangeable, RAM and main memory, and it's the main place that information goes. If information is not stored permanently, then it goes into RAM. If it is stored permanently, it usually goes into the hard disk. If you happen to lose information for whatever reason, if that is stored in RAM, it's permanently gone and you can't get access to it. If you store it on a hard disk and you for some reason close the file, you can reopen that file and it will be saved. So RAM is not so good at permanent files. The hard disk is really good at storing files. Okay, so that's the difference between RAM and the hard disk. As we say, ROM is what stores permanent information that will never ever change. Okay, so you hard code the information and it'll only ever do one thing. So, we've talked about, briefly, the different kinds of components that would be stored on a motherboard, and we've also looked at the basic input-output process of a computer and how it uses information and gives information out. We've also looked at the idea of RAM and ROM and their role inside of a computer, and that they're temporary holding places in terms of RAM or permanent storage in terms of the hard drive or ROM. However, the process that a CPU goes through is a little bit more complex, and this is called the fetch, decode, execute cycle. And this is the most important concept that you could possibly learn in computing, because this is how a computer does anything. So, what is it all about? Well, let's take my CPU over here. This is my brains. Let me just draw, a little squiggly brain right here. Here is your hard disk drive. And as I say, it's got the disk on there, and the disk spins around. So what's the fetch, decode, execute cycle about? Well, let's take an analogy. Let's say it's Christmas, and you have a lot of presents under the tree, and of course you will end up opening up those presents over time. So think about having a present under the tree as the instructions that are stored in the hard drive. What happens is the computer fetches that present, or that information, that data, and it takes it to the CPU. In our case, it's you. Here's you on Christmas Day, ready to open some presents. You don't know what that instruction does, or what that present is, so you have to decode it if you were a computer. If you're a human, that means you're going to open the present and find out what's inside, because it's currently a mystery. So you open that box and you find out, like, wow, it's a new toy car, or maybe a doll or something. And you say, right, I'm going to play with the doll now, or the car, or whatever it is. Maybe it's a games console. And that would be the execute part of our process. So in terms of a Christmas analogy, you get your present from under the tree, you decode it, you find out what's inside, and then you play with it, i.e. you execute it. So let's take that concept back to the actual computer. So inside the hard disk is various programs that you may want to use, such as Microsoft Word, or maybe any games that you may play, which is the classic example. And in order for the computer to actually run all that information, it takes your game, or your file, and it puts it into RAM, a temporary holding place. The reason it puts it into RAM is because RAM is a lot quicker than the hard drive. The reason is because you can go to any place in RAM at any time very quickly, whereas if you were to access the hard drive, you need to wait for the hard drive to spin around to the correct place for you to access that information. So once you are in RAM, once the program's there, so here's Microsoft Word maybe, and let's put a game in here. Once Word is in there, what it will do is the computer will fetch one line at a time, from RAM into the CPU, and it will decode that instruction. It'll find out what it actually means, and once it's decoded it, it will execute it and run it, and this is where things actually happen inside of the computer. So the computer, once it's executed that code, it'll go back to RAM and it'll fetch another instruction, and it'll decode it, find out what that instruction is about, and then execute it. It'll run it. So going back to that Christmas example, it's you going under the tree, so you going to RAM and fetching that present back to yourself. So here's you, the CPU. You open the present, find out what it is, you decode it, and then you play with it. You execute, and after you've played with it, you can go back and get another present from under the tree. The computer does this process millions and millions of times every second, and I'm going to very quickly show you now what that might look like. So these slides, which you will have access to, has a link to an online metronome, and a metronome just produces a sound repetitively. And what I would like you to try with this metronome is to change it so it runs for 60 beats per minute, 128 beats per minute, and 180 beats per minute. The 180 beats per minute represents one fetch, decode, execute cycle happening every second. And what would this look like? So if I just open this place now, hopefully it will work for us. So here is the metronome. Give it a moment to think about it. Here we go. So what you will hopefully find is that 60 beats per minute, you press play and it will start making a sound like dong, 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 dong. If I do 120 beats per minute, it'll go dong, 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 dong. And if I do 180, it goes dong, 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 really quickly. And you can think about these beats per minute as the amount of instructions that the computer is executing. So let's take a quick look at that in diagram form. So if it was 60 beats per minute, What that would do is we would say one instruction per minute. So fetch, for example. If it was 120 beats per minute, we would be able to fetch and decode. And if it's 180 beats per minute, we would be able to fetch, decode, and execute all within 1 second. Now, this is a very, very small amount of time to a computer, because a computer can run in anywhere of several thousand cycles per second. So that would look like 180,000 maybe. So it's executing 180,000 cycles, all the way to 3 million or more. So a computer is very, very fast. It executes millions, if not billions, of instructions every single second. This is why we use computers now, because they automate jobs that humans can do very slowly. So it gives us a lot of time to do other things. So I would highly recommend giving that website a quick try, just to convince yourself of how a computer fetches, decodes, and executes, and how this relates to beats per minute in terms of how often the computer is doing anything. So they are the 3 stages of the fetch, decode, execute cycle. What do we call these cycles? Well, you may have heard of this in other lessons, such as science, but we have something called a hertz, HZ, and a hertz means once per second. It's the number of occurrence that something happens in a second. In a computer, we also have several different measurements. You may have heard of these previously. So we've got the idea of a kilo. Now, you'll have heard of this, hopefully, from stuff like kilogram, kiloliter. Actually, there won't be a kiloliter. A kilogram, and a kilo means 1,000. Okay, 1,000. Mega means 1 million. So 1 with 6 zeros after it. Giga means 1 with 9 zeros after it. 1, 2, 3, 1, 2, 3. And finally, we get tera with 12. So 1 times 10 12s. And giga means billion, terahertz means trillion, a million. This is generally how fast a computer runs. So if a computer is 3 gigahertz in terms of speed, so it runs a billion times 3 hertz, that means it's running 3 billion instructions every single second, and that is incredibly fast. Now, I want you to be able to potentially have a look at your own computer's processor if you're able to do so. How can you possibly do this? Well, if you're using a desktop computer, usually you can search through the computer settings in order to find it. If you're using an Apple tablet or a smartphone, it might be slightly difficult to find the speed of your computer because it may be hidden. But if you Google your particular device, you will be able to find out the general speed of a computer. So most computers these days are dual or quad core, and what that means is there are 2 processors on the same motherboard, on the same chip, or there are 4 processors on the same chip. And each of those processors will run at usually 3 gigahertz per second. And that translates to 12 billion instructions every single second, which is quite a lot of instructions. So, what I would like you to be able to do as your first task for this lesson is to open the worksheet that is attached on the lesson resources, and it will look something like this. And what you would be able to do is to research various different kinds of CPUs on the internet. So you would be able to find an example of a CPU from one company, a CPU from another company, and as many different companies as you can. And you would write their speed measured in hertz in the next box along. And finally, you would note the price of each CPU. So every CPU has a price, has a cost in order to buy it, and is there any reason or logic to the speed versus the price? Does the price go higher and higher, the higher the speed is, or do they peak out at a certain price? It's worth a think. What I'd also like you to do is look at different kinds of storage devices. So here I've got the hard drive, and I would like you to find 2 different kinds of hard drive and 2 different kinds of USB flash devices. I would like you to get their names, find out how much memory each of them have, and write their corresponding price and do some comparisons. Because maybe one day you decide to make your own computer or maybe buy your own, and you would need to make the decision on can you afford it and what is the best cost efficiency for the machine that you're buying. So for example, if you're just using your machine to do basic things like PowerPoint and Word and so forth, you don't need a particularly good computer. If you are, however, playing games, such as all the new complex games or stuff that you might play on a PlayStation or Xbox, you will need a much bigger computer with a lot more processing power, because those games are becoming increasingly more intense. So please have a look at that worksheet, please have a complete. That would take you roughly 15 to 20 minutes potentially. Come back and we can talk through the final piece of this particular lesson. So, I hope today has been insightful on the CPU. So let us quickly recap what we've gone through. We've basically answered 3 different questions. What is memory, the difference between the hard disk or permanent storage and memory, and what is a processor? So to recap, memory is the temporary storage place that the computer uses to store all of its data and instructions while the computer is running. Once the computer is turned off, everything inside of that memory deletes itself, and when you load the computer again, there is nothing inside it. This is in contrast to other devices such as ROM. ROM is a permanent storage. However, it stores very few instructions and is usually used to boot up the computer or store other permanent instructions that may be needed when the computer is running. A hard disk is the device that you will store all of your important information to that you would like to keep permanently. It's stored on a disk, and of course the difference between RAM and the hard drive is that the hard drive is slower. However, it stores a lot more information. A hard drive can store anywhere between 50 gigabytes, depending on the kind of size you get, all the way up to a terabyte of data. That's 1 trillion bytes of data, which is quite a lot these days. The final thing we've talked about today is the processor, the CPU, the brains of the outfit. The CPU goes through a cycle of fetching, decoding and executing instructions in the system. So we do a fetch, we decode it, we execute it, and then once we've executed we can fetch another instruction for the computer to execute. It's going through this cycle millions and billions of times every single second. That more or less covers us for this particular lesson. So we've gone through a lot of different stuff. If you have any questions or comments, please leave them in the feedback on the It's Learning assignment area. Thank you very much for watching.